Yes. So these are the different types of conductors for the ACSR family, for ACSR family. Now, so let's see now article of what I will share you with the Sterlite. So this is the old one I am having. I will check and I will send you. If you are not able to see this, I will check and I will send you the new one. It seems that at 65 degrees, it is carrying this. At 75 degrees, it's carrying this. You can select the 75 degrees. It's just a way of representation. At how much temperature, how much it is carrying. Because in some projects, mostly they will go up to a temperature rating of 65 degrees. Because maybe there is a rise in the ambient temperature. That's why, that's the reason I told you that to accurately do this, we have to perform the conductor steady state calculation. From the steady state calculation, you will come to know that, okay, by passing of this conductor, this is the conductor temperature you can see based on your conditions, convention, radiation losses, as well as the solar heat gain. So based on that, you will consider this. So this is the simple ACSR conductor, which we already know about this. Now, come to this an article which was shared recently by Sterlite Power. You can see that now let's see. I already designed a conductor, suppose for the wolf. Okay. Now the wolf conductor is carrying 405 amps of current. Okay. Now this wolf conductor, I laid this conductor from suppose Noida to Central Delhi. Now this is the conductor I used a long back. Now due to the urbanization on all the households or the factories or industries or companies came in this region, so there is no space to construct a new line here. So there are two options. One, suppose if I want to increase the demand to the Central Delhi from Noida, because of having requirement, demand is there. So now the power I required, now the amperage I required is 800 amps. But the existing line can carry only 405 amps. So what to do? Whether go for a new line, or otherwise, because if you go for a new line, again, it will cost you more because of ROW issues, right-of-way issues, or it will take much time because of urban areas, everything. Cost is also high. So a new line could be a conductor line or a cable line. So in these cases, there is one more alternative that we have to replace this existing conductor with the big conductor. So now to carry 800 amps, this wolf is not suitable. So I have to go with a conductor name. I have to go to with a conductor name 800 amps, which can carry by Moose conductor. See, the wolf is 150 square mm conductor. Now I am increasing the square mm of the conductor for 520. So by this, let's see the weight of the conductor. The wolf conductor weighs nearly 72.6 or 726 kg per kilometer. But if you see the moose, it is 2000 kg per kilometer. So before, the structures I used to carry this wolf is only designed for the structures I designed to carry for wolf. Now, if I lay the same moose conductor now, I have to replace all the hardware and all the structures because they are not capable to carry because of more weight, which is nearly 3 times weight or 2.7 times weight. So again, total line to be changed out. So to avoid this, we recently have got a existence, the evolution of new conductors, with concept of we called as a high temperature low sag conductors, HDLS conductors, has came into the existence. Now these conductors, the advantage of these conductors is the same Wolf conductor of ACSR, same square mm, same weight, all same, similar to that, much more, no much deviation, plus or minus 10%. That conductor with other material, not ACSR, with other material, that can carry current of nearly 3 times or 2 times. 2 times. So you can carry nearly 800 amps with the HDLS conductor. So these type of HDLS conductors are presently evolving in the market. These are generally came into existence for these reasons, because it's very high cost to install new power lines, difficulty in acquiring tower sites right of way, time involved in the construction of new power lines, provision for future contingencies. By considering all this into the aspects into this consideration, so the advantage of the benefit of HDLS schemes into the picture. Now let's see in a brief about this. The HDLS conductor, why we are present need to shift the ACSR to the HDLS? Because of ampacity, high current ampacity, low sag tension, easy and rapid installation, reliable, equally reliable, and resistance is also very less in HDLS compared to the ACSR. Economics, because low line losses. Based on these factors, present, most of the projects are considering HDLS, again subject to the techno-commercial solution. Because HDLS conductors are very costlier than the ACSR conductors. Just look, if you need these HDLS conductors by considering the future expansions or whatever other things, then go with HDLS conductors. Otherwise, ACSR is quite sufficient for our analysis, for our applications. If you ask me, I will recommend that we will generally go for HDLS conductors where you can see the existing power lines to be replaced with the new ones. That too in the urban areas to reduce the line, to reduce the time, and to reduce the right of ways, and also the other kind of hardware, whatever it may be. So come to the next. So this is the way why we considering the HDLS. I don't want to spend much on this. I just want to skip. So these are the different types of families of conductor. HDACR, this is one of the type of conductor. Let's see this in a simple way. This is the one you can see. This is HDACR conductor, which comes under the HDLS family. Actually, the ACSR Wolf conductor, as I told, which can carry 362 amps, which can carry some 362 amps. But the HDACR aluminum conductor, having a same cages, same diameter, it can carry 843 amps, and the sag is also very less compared to this. But cost is high. See, TACSR conductor, which named as a thermal alloy conductor steel reinforced. This ACSR MOS, if I'm just comparing with the ACSR MOS can carry 664 amps. It can carry twice to that. ACSS, aluminum conductor steel supported ACSS conductor. Echo conductor. This is generally we are using for as a benefit of line losses in the 33 kV side, in the 11 kV side distribution side. The temperature, the current is high. The voltage is less, the current is high. To reduce the losses, these are the best conductors you can see there. The ACSR dock. If you see the ACSR dock, it can carry 284 amps. And Sterlite Echo conductor carrying 284 amps. If you see the I2R losses, see there is a red juice in the I2R losses. And this is a one more conductor, gap conductor, which is in-war type of conductor. 1574, same. Dull conductor. This is the ACCC conductor, all aluminum carbon composite conductor. This is one more good conductor in the HDLS family. Now, if you see the comparison of different HDLS conductors, like with respect to the power transfer, with respect to the line losses and the conductor price, let's talk about the power transfer. The ACSR conductor will carry 35% of the, suppose, at maximum conductor temperature. See, you can see all these conductors. You can see STACR conductors can carry, suppose it's carrying 100 megawatt of power. The ACSR can carry only 35 megawatt of power. See how much difference. In compared to the line losses with respect to the resistance, ACCC conductor line losses, this is the how it's go. ACSS, TACs are having the steel content. That's the reason these are having, even though they are good at the power transfer, but they are not well at the line losses. And if you see the conductor price, ACSR conductor is less cheaper. And if you go for STACR, it's nearly 4.25 times of the ACSR conductor. So now what's the question is, I will check how much losses I am going with ACCC and how much number of conductors I have to lay for it to transfer some 200 megawatt of power. And I will consider also price. By considering all these things, I will select which of the conductor is a best option for my application. Make sense? Team? Yes, no, please. Yeah, fantastic. So, just this is a simple comparison of the conductor team. See, I am having ACSR MOS, which having a cross-sectional area like this. And these are all the other conductors in the market, which are related to some ACSR HDLS family or some other conductors. So you can see diameter also very equivalent. Weight is also very equivalent. All the tension, everything is equivalent. But if you see the conductor, current carrying at 75 degrees, this is the case. But if you see the current carrying at maximum operating temperature, let's see, this is the change. This is the case. Okay, yes, we can do because we are having, that's for this. Now, as per, now let's do the simple calculation as asked by now you. Let's see. I want to send some 100 megawatt of power in 33 kV level. So to send 100 megawatt of power in 33 kV level, the current is nearly 1800 amps. Suppose, let's assume 1800 amps. 1800 amps. So now I am selecting the conductor based on this 1800 amps. So to carry 1800 amps, I am checking with the two conductors. One is ACSR, other one is ACCC. I want to do comparison with both of this. Let's assume the line length is 10 kilometers. The line length is 10 kilometers. To carry 1800 amps, in a line, if I go for ACSR conductor, I have to select, come to the ACSR, 1800 amps, I have to select a twin Markula conductor, or sorry, twin Bursmith conductor. Twin Bursmith conductor is required for my ACSR. So, let's see, I required twin Bursmith conductor. Now, if I see for ACCC conductor, ACCC, coming to the ACCC, which can carry 1950, yeah, with a single moose conductor. A single moose conductor. A single moose conductor. Sorry. Single moose conductor. Now, let's see. This is the rough team. I'm giving. Twin busmiss conductor. So, how many conductors I want? First of all, I'm doing the capital cost. How many conductors I want? For each phase, 2 conductors. So, 6 conductors I required for 10 kilometers. For 10 kilometers. So, 6 conductors for 10 kilometers, nearly you required 60 kilometer of conductor of busmiss. ACSR busmiss. And in the ACCC conductor, you required 30 kilometers of moose conductor. Moose conductor. So for time being, to make it a simple comparison with moose to moose, I will go through this here and I will check what is the moose capacity, 836. So 836 into 2, it's coming to nearly 1600 change. So we have to go for 3 triple moose here, right? Triple moose. So instead of the busmiss, I am moving to the triple moose to make it simple, say similar. Triple moose here. Okay. So I required 3 into 9, so 90 kilometers of moose conductor here. Suppose if moose conductor is, come to the next before page. If the moose conductor price is X rupees per kilometer, so I have to do 90 times of the X is the cost. Now come to here. If ACSR is X, then let's see the ACCC, which is 2.5 times of X. So 30 into 2.5 into X. So nearly 75 into X. So in this case, obviously the capital cost of my this is less compared to this. And I don't need to calculate the other things of line losses and the power carrying capacity, because obviously I know that the ACCC moose is having the low line losses compared to the ACSR. So no need to do the analysis. I can opt. This is the best option for me in the 33 kV level if you want to send the maximum power. If I get suppose a 105X here and 90X here, so additionally I am investing some 15 times of X rupees in this. And I will check the line losses if I lay for ACCC, and I will check the line losses of ACSR, and I will check how much amount of X I am saving per year. So if it is coming in the next, if I get my investment with respect with the addition of interest, all the things in the next 5 years, then I will go with the HDLS conductor instead of ACSR conductor. This is how we will calculate. To do this, because we are not having the resistance here, just I am explaining you. Fine, team. Got an idea? Because why HDLS is better now? Because in 33 kV high current ratings, this is the conductor best for me. That is a way of telling. Fine. So that's about this conductor team. So if you have any questions, anything, you can ask now. That's for my side. Again, I have to catch up with other batch in the next minutes, in the next half an hour. So I just want to end up for today. So any questions, you can please.
Yes, I mean,